Good afternoon, dear conference participants. Let me present to you the result of our research on the topic construction of cubic splines for interpolating functional dependencies and processing the results of experimental studies. Restoring functional dependence y for x on the basis of a discrete set of numbers is one of the important issues of computational mathematics. In the simplest case, this set is specified in the form of a table with two variables, xk, yk. K equals 0, 1, 2, to n, belonging to the interval a, b. Determination of the dependence y for x for large n is often carried out using splines. Usually, the so-called natural spline is used, which corresponds to the assumption that its second derivatives at the boundaries of the interval ab are equal to 0. In applied mathematics, there are problems with order boundary conditions, the consideration of which is of practical interest. This work is devoted to the construction of a spline with other boundary conditions, the consideration of which is practical significance. Supposing on the interval AB there's an continuous function y for x with continuous derivatives up to the third order. Imagine that at the nodal points x0 equals a, x1, x2, xn equals b, this function takes known values equal respectively to y0, y1, y2, yn. Let us consider the possibility of recovering this function for the entire interval ab using the cubic spline s for x given by polynomials not higher than the third order in the formula on slide. To ensure the continuity of the spline, it is necessary to require that the value of the spline at the nodal points s for xk has to be equal. In this case, the constraints in the polynomial ak are equal to yk. Let us emphasize the differences between neighboring coordinates of nodes and the values of functions at these nodes. The condition of the spline continuity implies that the equalities are fulfilled as follows in Formula 1 on the slide. To ensure the smoothness of the spline, it is necessary to require the continuity of the derivatives of the spline at the nodal points. It follows that in formulas 2, 3 on the slide. The purpose of the work is to develop an algorithm for constructing cubic splines with different boundary conditions. From formulas 3, 4, we have formula 7 or formula 8, where we have formula 9. We seek solution 9 in the form 13 with known coefficients. After substituting the coefficients of equation 9, a, b, c, d into expressions 14, we find forms 15 and 16. Case 1. Construction of a spline under condition you can see in this slide. The proposed algorithm was tested on the example of interpolating the function for the interval 0, 1. The relative calculation error for the number of nodes n equals 10 was about 10 to power minus 2. Table shows comparative data in the case of testing n equals 1000. Result you can see in the slide. It can be seen from table that relative interpolation error is about 10 to power minus 6. Increase of the number of nodes to 10 to power 4 leads to an increase in accuracy to 10 to power minus 10 to 7 to 10 to power minus 8. Case 2. Construction of a spline under conditions. As the spline value S for A is equal to y0, so according to 1 we have the value of the first derivative with x equals A is equal to form 21 and 22 when we can identify the coefficient. Case 3. Construction of a spline under conditions. Let's calculate the coefficients of spline at terms form 25. In this case, forms 26. The algorithms for constructing cubic splines with various boundary conditions have been developed. The second derivative takes arbitrary values at the end of the spline. A special case in the natural spline when the second derivative at spline ends in equal to 0. At one end of the spline, the first derivative is given, and at the opposite end there is the second derivative. The first derivative is given at two ends of the spline without any restrictions on the second derivatives. It is shown that a number of problems with other boundary conditions can be solved using the proposed methods. The considered algorithms are recommended to use while interpolating functional dependencies and processing the results of experimental studies represented as a discrete set of pairs of numbers. Thanks for your attention.